This here's from the earth.nullschool.net page. Really cool site, shows current conditions, but even better, we can see past conditions as well. So I'm going to go ahead and zoom in to Indiana. And so what you can do also is if you zoom in close enough, you can see the rivers, which is about as good as we can get. It doesn't show, like a normal map would as far as cities and all of that, but we know, okay, if that's the Ohio River, if that's Lake Michigan, here's the distinctive shape of Michigan. We know this is probably the 40-degree north latitude line, and we know Indianapolis is just south of it. So I don't know, right about boom there. And I put a dot, and what do you know? You can see the latitude and the longitude, so the location, the geography of this particular dot. And so it says, to give me useful information, and I can change meters per second, whatever this is, knots, miles per hour. So you can see how I click on it, how it changes the units. Something to keep in mind as you're working with your own particular data. So now what you can do is you can also not only do location, kind of go around different spots, so identify your tornado location, and then put a dot there, wherever it's located, and you can kind of try to guess. I wish there was a way where you can essentially enter in your lat and your long as it's provided there from your original tornado link. Usually it should have a location as far as where it happened, and then you can go ahead and try to find it somewhere. And so all of you will be somewhere in this general area. So like I said, this is a snapshot for this one moment in time. Today, let's go back in time and look at other variables pertinent to our assignment, pertinent to what we've been learning. And so if I go ahead and click on Earth over here, and you'll see, oh, I got all kinds of information. And so what this shows is whatever the data, the date. So you can change from local to UTC time. Probably local would be better. To use local, since it's kind of whatever, it'll help you with your tornado as far as its location and its particular time. It'll be defined in your notes and in your readings and whatever wherever your research would be a particular time. 3 p.m. Indiana time. UTC kind of it's just more complicated. I won't go there. All right, so scale here. This is something to keep in mind is scale. So as you look at different variables, go to the scale, of course, low and whatever, and then high and whatever it might be. All right, and all these various variables we're going to go ahead and look at, but let's go ahead and look at this calendar, and I'm going to go ahead and use my case study that I'm going to be using, and so you can go back all the way back to your particular tornado, all as far back as 2013, to find the conditions for a particular day and time. So I'm going to go back to June 25th, of 2023. That's when my case study, my particular tornado occurred. And so here we have the particular conditions. And so I'm going to zoom out a little bit. And so whenever you're analyzing your particular tornado, this is the stuff I want to see. I want to see you being able to interpret what you see here and all this particular data, in particular the ones that I'm going to highlight right now. So making sure that your tabs say air, wind, surface, and wind, what we can see here is, okay, this is characteristic. So continue to ask, is this characteristic of what I've learned is a thunderstorm and a tornado? And we've learned overwhelmingly that in where we live here in Indiana, low pressure centers from mid-latitude cyclonic systems bring with it changing weather, and the key there is the arrival of a cold front. And so for all of our tornadoes, we're going to see a particular pattern, knowing what I know, of a low pressure center going through kind of the northern part of the state or in the north of Indiana, and then subsequently a cold front sweeping around the southern edge of that low pressure center. And that southern edge is going to sweep right across Indiana, bringing with it, once again, the characteristics of a tornado and a thunderstorm formation are changes in temperature, changes in air pressure, changes in wind direction. If you get all those ingredients combined, changes in precipitation, changes in humidity, then that's the recipe for tornado or thunderstorm formation. So first off here, we look at the surface winds. They're coming from the south. Very characteristic of low pressure areas. And so right there's a low pressure center. Once again, low pressure areas, as we learned in week 1, inward spiraling and counterclockwise in the northern hemisphere where we are located here. And further, we can see these wind speeds are really fast through here. And so we're bringing with it very fast winds. And so once again, we're thinking about tornadoes. They don't typically happen in kind of stagnant air. They happen when you have strong winds coming, bringing quick changes in temperature, quick changes in wind, quick changes in the types of weather that were found in this particular area. And so right now, here in our dot, I'll go back to kind of where we surmise Indianapolis would be. For this particular tornado, it happened just south of Indy, there in Greenwood. And so here, at this particular time, before this particular low pressure moved in here, surface winds coming from the south. Very important. The winds at the surface were coming from the south, coming from south and the west. Warm, humid air. Think about the Gulf of Mexico down here. All right, next up, let's look at temperature. So we should see, once again, as well, we should see temperature differences. And now, if I go ahead and I zoom out, I see temperature differences. I see up here greens and yellows, were down here reds and oranges. And once again, here's our scale. And so green being cooler temperatures. I can go ahead and click on up here. And so up here in this part of the low pressure area, once again, the low pressure center right there, up here, it's what's changed? 56.9 degrees Fahrenheit, whereas down here, 90. So that's a 40-degree difference here. And so once again, as this sucker moves across, it's going to bring with it changing weather characteristics. And we can do also is we can start putting this into motion. So here is going one, what was that, from 6 o'clock local, 7 o'clock local, so you go by the hour, and then these here, in this case, is toggling every 8 hours, so moving it faster along. Do we see evidence of changing conditions here in our location? Yes, we do. And now it's yellows and greens. The reds have long gone. So we're seeing changing temperatures. And so there's no doubt that this particular moment in time for this particular tornado and this thunderstorm, it's no doubt that it had the ingredients in terms of temperature differences. You can really even see that more so if I look at another particular case study, which I'm going to go ahead and do that right now. So I'm going to go to our other one that we've looked at, and that's from the end of March. And so here, very drastic differences. I mean, that's huge difference. And going up here, 27 degrees, whereas just over here, 30-degree difference, and you're still in the same state of Minnesota there. So this particular tornado and thunderstorm, maybe you'll have one in which it has a good temperature gradient, in which over here, completely different characteristics than over there. Notice the winds, different directions, coming from the south, coming from the north. All right, I'm going to go back to our previous one that we've been looking at from June 25th, the Center Grove one. So now looking at relative humidity. So I'm asking myself, do we have the characteristics of a thunderstorm and a tornado? And we're all going to say yes. We all have these characteristics. I chose tornadoes and thunderstorms of significance. So they're going to have evidence of this. It's just I want you to show me, in this case, maybe a screenshot of what you see here, or maybe adding a map that you might include from a different link I've added to this assignment. And so here the relative humidity, putting it in motion. So highest levels of relative humidity, highest amount of moisture in the air, we can see right there. And so in this particular case, we see this low pressure coming through this particular area and bringing with it high levels of relative humidity as it's coming through Indiana. Once again, Indiana, keeping our location there, moving through. And so here we have a low pressure coming through, bringing with it precipitation, storms, changing weather, all those things we associate with, once again, thunderstorms. Next up, I'm going to go look at CAPE. This is that variable, which kind of, what it does is it does a good job of saying, okay, is there the ingredients in the atmosphere for convection? And once again, convection is the key for thunderstorms, going back to week 1, week 2 content. And so does particular area have evidence of it? And hopefully you do. Hopefully you can see this. And so I'm going to go ahead and put this in motion. So kind of when we think about this particular tornado, local was midday, mid-afternoon. So kind of we think about 1 o'clock, 2 o'clock. What are the conditions? So what are the conditions ripe in Indiana for thunderstorms and tornadoes during the event that you've been given? In this case, most definitely yes. And so higher levels there are white. And so what it's doing, so once again, this is a measurement that's measured in joules per kilogram. And so 2207, if we think about, okay, what was Indiana? What were we just a couple days ago or a few hours before that? 0. And so we didn't have that convective, that potential convective energy in the air, but in a day or two, we most certainly did. Also, total precipitable water, another good one to use. And so here we're going to see blues being higher, and then the absence of precipitable water being black. So we're going to see that kind of on this other side. And so, wow, what a spiral there. We can really clearly see that. So I'm going to go ahead and put this in motion here. And do we have the ingredients here in central Indiana for a tornado that occur on June 25th, 2023 in the afternoon? Most certainly we do, based on this evidence here of higher values of precipitable water compared to earlier times of the day, but also other locations. We can also continue on looking at mean sea level pressure. So mean sea level pressure, we should expect to see a black hole. So in this case, low pressures are shown as darker, higher pressures shown as lighter colors. And so we should see that low pressure area, and we do. And once again, if a low pressure center moves across the northern part of the state or north of Indiana, just north of Indiana through Michigan, then we have very much the conditions for have a cold front come sweeping across its southern side, and coming across here. If this low pressure, if this black hole was down here, we wouldn't have those worries at all. We'd have no chance of a thunderstorm. We'd be in this cold, dry air that's on this other side of this low pressure center. But because of here, in this particular moment, with this warm, moist air coming up from the south, we have characteristic of a low pressure center, sucking in that warm, moist air. And once again, when that warm, moist air comes into contact with that cold, dry air coming in this other direction, then we have once again frontal lifting, which then can help that convective energy help lift and help trigger a thunderstorm formation. Now I'm going to change it back up and go over here to wind. And so now I'm looking at the surface winds. So, okay, now there's a term called wind shear. It's a very complicated term, but this is a simple idea here. And so at the surface, do we have winds going in one direction, and then up towards the clouds, in the upper level part of the clouds, where we have cloud or thunderstorm formation, do we have winds going a different direction? The reason why I mention this is, if we do, then we have the ingredients necessary for that horizontal rotation that we call a mesocyclone, which then of course can become vertical, and that's just the origin of a tornado starting as a funnel cloud and then eventually touching the ground. So show me evidence of a wind shear. And one way to do that is to look first off at the surface. And so that's what we have here. We're looking at the surface winds, and we're really focusing in on what direction are they moving. And they're moving from the south. And if I go ahead and move just a little bit farther in time, let's go ahead and get closer to, this is right when my thunderstorm was happening. You can see that cold front clearly defined there. Warm, moist air on this side, cold, dry air coming crashing in along this front. Great evidence of this. Now what's happening? Let's go ahead and go up in altitude. And to do that, let's go click on the 500. So this is really showing wind speed here. Now we're seeing very fast wind speeds. Now keep in mind, this is up in the upper levels. This is at a higher altitude. And so here the wind speed's much faster. If we go ahead and let's switch this to miles per hour. We're looking at very fast, 73, 74. When we look at the surface, we're looking at just 10, 15 mile per hour winds. Still strong with 30 mile per hour wind gusts with that storm. However, if you go up in altitude, there's less friction and the winds are quite faster. But what do we see here? The wind direction clearly showing wind shear coming in this direction. And not only is it coming, it's not kind of cruising along like it is up here where we have these troughs and these ridges. It's coming quite quickly, noted by the color, but also hopefully the animation we can see that. Hopefully you can see that animation is really showing. So wind shear. Do we have, in this case, at the 500 level, do you have these darker color, this red color, this higher speeds compared to maybe, let's say, over here? We should. And how does that compare to the surface? We're going a different direction. So at the surface, we're coming along through here, and so now we're getting, once again, the ingredients for mesocyclones. So even further, I'm going to go ahead and I'm going to put the 500 on and then add CAPE as our overlay. And so here, wind shear considerably. We have very, very strong upper level winds. And at the same time, we have a lot of convection, that convective available potential energy. It's there. And so we have the two key ingredients here for thunderstorm and tornadic activity in this particular part of Indiana at this one moment in time.